Hello and good day. We'll be going over negative exponents today, CO13, which we like to stay positive here, but today we are forced to go a little bit negative so you understand what they mean. So we are going to, again, not just regurgitate, but look at why negative exponents do what they do. And we're going to go to what algebra is really all about, and that is patterns. I'm going to scroll this down a little bit so that we can get both the table and the rule on the same page here. Perfect. Green is in timeout, so we're using blue. Okay. So we are familiar with something like 2 cubed. I'm going to make this table vertically. It should fill up the entire page. So don't start your table right in the middle. Don't write super big. But we're going to try and make this all fit here. So 2 cubed, 2 to the positive third power. We know what this means. We understand what it means. What is it? Okay, so in expanded form, it's 2 times 2 times 2. And what's the value of it then? 8. Okay? So what we're going to do here, what we're going to kind of test here is what happens when we decrease our exponent by 1. Because if we continually decrease our exponent by 1, Schlafer, right? Yeah? Do you know what you just agreed to? Oh, you just agreed to take out my trash for a week. Thank you. Pay close attention. When we decrease our exponent by 1, eventually we're going to go negative, right? So let's just see what happens when we start that. So instead of 2 cubed, we have 2 squared, which in expanded form is 2 times 2. And that gives us 4. Decrease the power by 1 again. 2 to the first is just a 2, which is the value of 2. So the two patterns that are, well, 2 of the patterns are kind of several here, but we're decreasing our exponent by 1. What's happening to the value of each expression as we do that? Drew? Being cut in half. Why? Because we have 1 less 2, right? We aren't doubling it as many times as we were previously, okay? So going back to yesterday, when we decrease our power again, this is kind of another example of why any base to 0 power is 1. If our solution, our value keeps being cut in half, half of 2 is 1, right? 8 or 2 to the 0 power is 1. It's not really defined here. We can't really put any expanded form to this, but it equals 1. All right, negative powers. Decrease our exponent yet again. What do you think the value of 2 to the negative first is? Blake? Well done, Blake. It's not negative 2 like a lot of people think. Negative 2 doesn't follow the pattern here, right? The pattern is our solution keeps being cut in half. So following that, to the negative first would be, he said 0.5, but I'm going to write it as 1 over 2. Okay?
Well done, Blake.
So 2 to the negative second power is going to be what? Joey? 1/4. 2 to the negative third power is going to be, Mackie? 1/8. Okay? So looking at the similarity and the differences between like 2 cubed, 2 to the positive third, and 2 to the negative third, looking at 8 and 1/8, how are they alike? How are they different? Kind of, Adam. The reciprocals, right? 8 can be written as 8 over 1. The reciprocal of that, 1/8. Okay? We see the same thing here with 2 squared and 2 to the negative second. 2 squared is 4. 2 to the negative second, 1/4. Right? And then finally, also with the, I'll put a dot here. 2 to the first and 2 to the negative first, we have 2, and we have 1/2. So first thing I want to point out here is a negative exponent does not give you a negative value. A negative exponent does not mean the base becomes negative. What it means is that instead of expanded form for 2 to the first being 2, expanded form for to the negative first is 1 over 2. Instead of 2 squared being 2 times 2, 2 to the negative second is 1 over 2 times 2. Instead of 2 cubed being 2 times 2 times 2, 2 to the negative third is 1 over 2 times 2 times 2. That's how we get to 1/8. What a negative exponent does is it basically moves the action here, moves the expanded form, moves what's going on to the other part of your fraction. Right? Another way to write 2 to the negative third in the numerator would be to write 1 over 2 to the positive third. So a negative exponent does not make a base negative. What it does is it moves that base to the other part of the fraction. That's a sound effect. Sorry, this is YouTube. That's a sound effect for your mind being blown. Right? Who knew such cool things existed? Oh, you already did? Oh, sorry, it wasn't very exciting then. Blake, you already knew too? Oh, well, hopefully someone learned something new today. Otherwise, why do we even do this? Okay? Because you're force field. So our rule for this, when a base has a negative exponent, okay, I'll give you an example. A coefficient, nothing happens to the coefficient. This is another one where the coefficient stays the same. Okay, if it's not affected by the power, nothing happens. Okay, if it's not affected by the power, nothing happens. Our exponents moves to the other part of the fraction and becomes positive. Okay, moves to the other part of the fraction and becomes positive. Moves to the other part of the fraction and becomes positive. Okay? And the base, in all of these, we had a base of 2. In our final answer here, 1/2, 1/4, 1/8, yeah, we multiplied it out, but the base stays the same. It moves with the power, but the base stays the same. Okay? The base moves with the power, but ultimately stays the same. And I add that in there just as a reminder that it does not become negative. Biggest mistake that folks make with negative power. So it does not make the base negative. So it moves with the power, but stays the same. How are we doing so far? Okay? No? All right. Let's take a look at some examples here. Okay? 7n to the negative third. Do we have a coefficient here? What is it? 7. Is that 7 going to move? Is it going to change at all? No. The coefficient stays the same. What moves here is this base with the negative exponent. So instead of, because right now everything's in the numerator, okay? Instead of n to the negative third in the numerator, we can rewrite this to still have the 7 in the numerator, because that stays the same, it doesn't move. But now in the denominator, it's n to the positive third. Okay? I said to start this that we're usually positive here. We're actually turning negativity into positivity here. That's what we're doing, right? 7 over n to the positive third. The coefficient didn't change, stayed where it was at. The base moved with the exponent but didn't change. It's still an n. And the power became positive. 12x to the negative ninth times y. What's being moved here? Drake. and only x to the negative ninth. The 12 is a coefficient. Nothing happens. The y, it has a positive power, positive 1. We don't need to move it. Okay? We're only moving what we have to, and in that case is at x to the negative ninth. So in our numerator, we still have our 12, still have our y. In the denominator, x to the positive ninth. Okay? Again, just bringing joy to these expressions, removing the negativity. Next one. What's being moved? What's being moved? Joey?
The n to the negative fifth.
N to the negative fifth. Where's it going?
It would go up to the numerator of 2.
Up to the numerator. Exactly. Okay? 2 stays where it's at. It's now n to the positive fifth. And our 3 stays in the denominator. Sometimes you might have more than one thing to move. Last one here, t to the negative third over c to the negative 10th. We can rewrite this to be c to the positive 10th over t to the positive third. Right? Negative 3 goes down, becomes positive. Negative 10 goes up, becomes positive. Okay? Questions that have arisen so far? A lot? Well, please ask one of them. Okay. Any you'd like to do together? Any on this page that look like one you want to talk about? Joey?
The bottom row, third one.
Joe? Julie, right there. Yeah. The third one here, our b to the negative ninth, will move down. Our a squared is good because that's already positive. Don't have to move it. Our n to the negative 7th is going to move up. But the y to the 11th, positive power, it's all good. We don't need to move it. So our numerator will now be a squared n to the positive 7th, right, over b to the positive 9th, y to the 11th. Okay? Looking at the next page, okay, we kind of expand things a little bit in that it's a review of what you've done. We've got the first row is all multiplying by the same base. You can use the rules we've discussed so far, but remember, expanded form can kind of be a backup. If you're unsure, look at it in expanded form. That can help you visualize what's going on here. The second row is dividing by the same base. The third row deals with 0 powers. And then the fourth row is negative powers, what we just learned today. So we're about halfway through the unit now, maybe a little bit more. I just want to kind of review what we've already done. Because your power objective for this unit is to use multiple rules at the same time. And so we're eventually going to combine all these rules together into like mega awesome exponent expressions. It is. Okay. So any on the second page that you want to talk about as you look at them now before we sign off and you get to work on this? Drake. That negative 7x to the 7th one? Yep. Okay. So for this one, we are multiplying by the same base here. So we go back in our minds. We think, okay, CO10 multiplying by the same base. My coefficients are multiplied. So our coefficients are negative 7 and negative 3. So they'll combine to give us positive 21, right? And then I've got x to the 7th and x to an x squared. How many total x's do I have being multiplied together? 9, right? Our rule for multiplying by the same base is the powers are added, right? And then I've got y and y to the 9th. How many total y's are all being multiplied together? 10. So y to the 10th. and that would be your final answer. You can't go any further because we have different bases, x and y, you can't combine them. But if you need to know where to look, this one is CO10, this one is CO11, third row CO12, and then of course the last row is what we did today, CO13. All right, so that's where you can look for help. Yeah? The 13 and the 8? Well, are those exponents? No, they're coefficients. You would keep them. You would simplify them in the fact that the signs cancel out, right? Because they negative divided by a negative is a positive, but you wouldn't flip them, right? That's only with negative exponents do we do that moving between the numerator and the denominator. Okay? Good questions. Anything else? Okay. For tonight, due tonight, the football pick'em sheet for week 3 is due tonight. Khan Academy is due tonight. This homework is due on Monday because tomorrow is a retake day. So in a kind of homework-free night, in the sense that you don't have to do this for tomorrow, Khan should get done. The football sheet, if you're in that, should get done. And tomorrow being a retake day, practice work for the entrance exam should get done. Tomorrow is also the last day you can turn in your math packet for me to review. So if you need to finish that up tonight, that should get done. If you gave me practice work or math packets earlier in the week, you'll get those back tomorrow so you can do your retakes or look over your math packet during class. If you're all caught up on math packet, all caught up on practice work, everything else is done, then Khan Academy will be assigned tomorrow morning for you to work on during class. Okay? Anything else? All right, folks, that's how you math.